Hello, welcome again. We are solving GATE 2022 Mechanical Engineering Set 2. Question number 30 is a rope with two massless platform at its two ends passes over a fixed pulley as shown in the figure. The disc with narrow slots and having equal weights of 20 Newton each can be placed on the platform. The number of discs placed on the left side platform is n and that on the right side platform is m. It is found that for n is equal to 5 and m is equal to 0, a force F is equal to 200 Newton. Refer to part 1 of the figure. Is just sufficient to initiate upward motion of the left side platform. If force F is removed, then the minimum value of M, referred to part 2 of the figure, required to prevent the downward motion of the left side platform is in integer. So this is the first case, and this is fixed pulley and F is applied, and there are n number of discs, so n is 5. Okay, and this is the second case when force has been removed and number of discs has been placed. So number of discs are m and these platforms are massless to prevent its downward motion. Okay, so in the first case there are two methods to solve this. Let us one is assuming friction and other is without assuming friction. Suppose mu is the coefficient of friction between the pulley, okay, and the pulley is not smooth. So the F will create a tension T1 that is equal to F 200 Newton. As the as the weight is moving upwards, so pulley, so this is also moving in downward direction. Okay, so the pulley is rotating in this direction. Okay, so this will be tight side, this will be slack side, and the tight side tension is 200 Newton, and slack side tension will be here 200 into 5, that is 100 Newton. Okay, so the ratio of slack side, tight side to slack side is T1 by T2, and it is equal to E raised power mu theta, and theta is pi, and theta is your pi radian. Okay, and mu is your coefficient of friction, because theta is angle of wrap and this angle is pi or 180 degrees. So if we from this we get mu is equal to 0.22. So in the second case, its motion in downward direction has been prevented. Okay, so it will become tight side. So T4 is the tension in this, and this tension is equal to 100 Newton because it is provided by the number of weights, and these weights these weights 100 Newton. There are 5 discs and these weights for 100 Newton. And in the slack side, suppose there are m number of discs, and so the tension is 220 into m. So by using this T4 by T3 is equal to E mu theta, because now this is your tight side, this is your slack side. So we get m is equal to 2.5, and in integer it is 3. So this is the one method when the friction in the disc is considered. Okay, now let us assume that the disc is frictionless. Okay, and the force F provided produces T tension in this thing, and this T tension is same in this aspect. Okay, and equilibrium condition is maintained, and so that the acceleration is equilibrium condition is maintained by applying inertia force. Okay, so this F produces A acceleration in this thing, and so for equilibrium the inertia force will act in downward direction, as these are this is 20 kilonewton or 20 Newton, and there are 5 discs. So mass will be 20 to 5 by 10, and inertia force will be in downward direction, and weight will also act in downward direction. So weight will be in downward direction, and this F is creating T. So T will be in these, T will be summation of these two, 10A plus 100. Okay, and F is equal to 200, and so it is equal to t. So from this we get a as acceleration of the masses in upward direction is your 10. Okay, now when f is removed, okay, then it will start uh, moving downward. Now to prevent its downward motion, number of suppose m discs are placed. Okay, so if m discs are placed, then these discs are restricting its downward direction by uh, providing acceleration in downward direction. Okay, here, so so by uh, by providing, because this is in upward direction, okay, and so inertia force here will be in downward direction, because this these disc will these disc will try to move down, so it will be subjected to an upward acceleration. Okay, so upward acceleration means inertia force in downward direction. Okay, so because initially it was moving with acceleration a. Okay, to bring that a equal to 0, the a downward acceleration has to be provided by this. Okay, so in this direction, so if the downward acceleration is in this direction, to bring the acceleration 0, so this weight will also be to an upward acceleration, so inertia force will be in downward direction. Okay, so t will be again same, that is 20 into 5, because the tension is provided by this. Okay, 20 into 5, and inertia force will be m into 20 into 10 by 10. Okay, m is number of discs. So from this balancing 100 is equal to m into 20 plus m into 20, we get m is equal to 2.5, or minimum value of m is 3. Okay, so that is answer. Next, for a dynamically system governed by the equation x double dot t 2 xi omega n x dot t omega n square x t is equal to 0. The damping ratio is equal to 1 by 2 pi log e raised power 2. The displacement x of this system is increased during a hammer is measured during a hammer test. A displacement peak in the positive displacement direction is measured to be 4 mm. Neglecting higher power greater than 1 of damping ratio, displacement of the next uh, peak in the positive direction will be dash mm in integer. Okay, so we have in that is a case of damped vibration. Okay, and in case of damped vibration we have logarithmic decrement as minus 2 pi omega 2 pi xi by 1 minus xi. As we have to neglect the higher power, so we'll this quantity values for, so this quantity this will be 0. Okay, so this ln xn plus 1 by xn will be equal to minus 2 pi z. So xn plus 1 is the amplitude in next cycle, and xn is the amplitude in nth cycle. Okay, so as the amplitude is decreasing in subsequent cycle, so it will be equal to minus 2 pi xi. Okay, and xi is equal to 1 by 2 pi log e2. Okay, and 2 pi will cancel out, so it will be log e2, and so it will be xn plus 1 by xn is equal to, xn by, if we take this minus sign, then it will be xn, or it will be xn by xn plus 1 is equal to 2 because of this minus sign. So xn is given as 4, so xn plus 1 is 2. Xn amplitude in the x-axis is given as 4, so xn plus 1 is 2 mm. Okay.